Dinesh, you can share your screen.
Now we able to see, sir?
Yes,
Yeah,
you can
thank
start,
you.
Dinesh. Time is already running. Yeah.
Sorry. Good evening to everyone present here. Myself, Dinesh Kumar. I am doing my master degrees in science and technology. Here now I'm going to present my topic, a texture-based melanoma detection and classification using EGG16 and DESNet 121. These are the tables of content and introductions. Nowadays, when the population getting increases on the same way, diseases also increases. So on the same thing, the most dangerous disease is skin tumor. Skin tumor. Uh, when we find early this disease, we can save our life from life threatening. So my project is going to detect how this melanoma gets affected. If melanoma is detected early, which is classified into 5 stages. In stage one is the malignant tumor is conflicted on the upper layer of the skin. On stage one, the cancer cells are in both epidermis and epidermis. The stage two is melanoma is defeated by tumor thickness and ulceration. These cancer cells in both epidermis and epidermis. And the stage three is defined by level of lymph nodes involvement and ulceration. In 11, stage 4, the cancer cells spread beyond the original tumor sites and regional lymph nodes to more distant areas of the body. So these are the stages in melanoma detections. In my proposed systems, sorry, in the current world, we are using the dermatology scope is for detecting the melanoma detection. This dermoscopy shows capture the dermoscope images that only identify the top layer of the skins. So it's very difficult to find. So that we are using the texture-based directiveness algorithm for early detection of this. These are the techniques we are using: segmentation of images using texture distinctness and lesson segmentations, and classification of the images using deep learning techniques such as VGG16 and DESNet 21. This is my abstract. The abstract is texture distinctness lesson segmentation algorithm with the VGC16 and DESNet 21 is proposed. The proposed model is tested with the skin cancer images of benign and malignant datasets for Google. Moreover, 3,000 datasets used for comparison and classifying. The pre-processing is done by getting the input images. The pre-processing steps are followed by this: the grayscale techniques and the Gaussian filter effects and O3 threshold is applied to the input images, and lesion is traced and unwanted pixels are removed from the threshold images. After that, the threshold lesion images got passed into the texture distinctness. The texture distinctness consists of two types of process: is a spare texture distribution and a texture distinctness matrix. The structured texture distribution and texture distinctness matrix are done by applying k-means clusterings on the images and finding the Gaussian mixtures modeling. The region classifications of the images are done by using the SRM segmentations on the image and the global detections of the images done. The images get segmented by the above mentions with the distinctness-based discrimination. Totally we are testing with more than 3,000 goggle data sets. These are the existing system. I have already spoken about this. This is our proposed system. This is the block diagram of the project. In this block diagram, we are initially doing the pre-processing of the images. We are getting input from the images. On these images, we are applying this type of process: grayscalings and Gaussian filterings and also thresholding and tracing links and remove unwanted skills. After that, we are doing the texture distinctness selection segmentations. This consists of three types of processes: k-means algorithm segmentations and SRM segmentations. After that, we are doing global edge detections. After this segmentations process, we are classifying the images with our pre-trained models like VGG16 and DESNet 121. The VGG16 has 16 layers for classifying and classifying the images, and the DESNet is having around 121 layers for classifying the images. Compared to both compared to both the data models, we have get more accuracy while we are using the more number of layers. So why we are using VGC16 for comparing with when we are using low number of layers, how the output gets, and when we are using the high number of layers, how the output is modified. So that we are using the two types of classifications here. These are the methodologies applied on our project. These are the experimental results. After applying this all the above methodologies, we could observe that final segmentation of the skin lesion from the non-lesion area. After doing the texture segmentation of the skin lesion, we could observe that the exact texture of the lesion is segmented from the lesion skin. By this, we could observe the area of the lesion is clearer than the abnormal sections. We are using two types of tools for this process. We are using MATLAB for the segmentations and pre-processings, and we are using Google Colab for our classification process. These are our references we are using for this project. Thank you, sir.
Thank you, Dinesh. Thank you so much for your presentation. Any questions?
Yes, sir. It's audible.
Yes, sir.
Small suggestion to you. You have mentioned in the references about the what you have referred for.
Yes, sir.
Look at the references. The fresh data you have taken from 2020. Am I right?
What's up, data?
The recent year of publication you have chosen is 2020.
Yes, yes, sir. Yes,
we are in the 2025. So
yes, sir.
we are almost 5 years ahead. Okay.
Yes,
we
sir.
are referring some of the recent journals.
Okay, sir.
Field, it will enhance your research proposal, no? Okay,
sir. Actually, these references are getting most latest, sir. We had seen very older references also, so we have picked only the latest this references here, sir.
But including that will be better. Okay. Thank you.
Okay, sir. Thank you for suggestions, sir. Thank you.
Thank you, Dinesh. Thank you so much. Let's move on to the next participant. So I would like to welcome Pandian Saraswati Yadav, Engineering College and Technology. So I think the coordinators are here with us. And may I know who is going to present first from PSP College of Engineering and Technology? Okay, give me a minute. I have a list, so I'll call out so that you can come and present. Okay, give me a minute. Shivani, are you ready now? Shivani, can you hear me?
Yes, sir. Yes, sir.
Okay, great. Yes, Shivani, can start your presentation.
Yes, sir. I'm Shivani from Sedu Institute of Technology, sir, and my title is Human Activity Recognition App using Flutter, sir. Yes. The Human Activity Recognition identifies and classifies various human actions like walking, running, and starting using sensor data from mobile devices, sir. The main goal is to develop a cross-platform mobile application using a Flutter framework to recognize and track users' activities in real time by the smartphone sensors like accelerometer and gyroscope. The app provides the users with accurate insights into their daily activities and promoting health monitoring and personal productivity while ensuring a seamless experience on both Android and iOS platforms. As smartphones are equipped with advanced sensors like accelerometer and gyroscope, the accelerometer which uses for speeding up and slowing down and also a changing direction. It can changes on movement and orientation. And the gyroscope is used to measure the rate of the rotation, how fast an object is spinning. This machine learning algorithm, the app processes the collected data to accurately recognize the different activities. Developed using Flutter framework, the app ensures a smooth and consistent user experience across both Android, iOS, and web platforms. This application aims to provide users with valuable insights into their daily activities, enhancing the personal productivity. The overall goal is to encourage the healthier lifestyle and enhance the personal productivity throughout active tracking. The Flutter app utilizes the advanced activity recognition techniques to produce real-time human pose estimation, including key points and skeleton points, enables the user to track and analyze their physical movements effectively. And then physical activities by providing actionable insight with their movement patterns, promoting healthier lifestyle, and improving overall fitness. Next, the system architecture I used in this sensor, accelerator, and gyroscope collects the real time from users' movements, data processing, and machine learning, which cleans the data, applies the machine learning models to classify the activities and generate a post estimation, which is a skeleton points. Next, I have to move to the implementation. In this human activity recognition app is implemented using the Flutter framework, enabling cross-platform functionality for both Android and iOS. The app gathers the data from the smartphone's built-in sensors like the accelerator, accelerometer, and gyroscopes. This sensor continuously monitors the user's movements and feed real-time data into the app. It displays the activity results in their user-friendly manner, allowing users to view logs, summarizes, and notifications about their physical activities. Additionally, the app has options to store activity locally or sync to the cloud for backup process. These are the outputs images. The results are the app's machine learning models such as SVM and CNN have been optimized to balance both the speed and accuracy. These models achieve an average accuracy of 95% of activity recognition with minor deviation based on their environmental conditions and sensor equality. We are facing some challenges into that. First one is sensor noise, second one lightning condition, and third one is battery consumption. First one, the sensor noise. Inconsistent sensor readings due to noise, especially in highly dynamic or crowded environments, can impact data accuracy. The second one, the certain post estimation, poor lighting can reduce the accuracy of the skeleton point, though this is less of an issue in non-visual activity tracking. The final one is battery consumption. Real-time data processing and continuous sensor usage can lead to higher power consumption affecting battery life. And I'd like to conclude this project. This human activity recognition app developed using Flutter successfully classified and tracks various human activities such as walking, running, sitting, and cycling by leveraging mobile device sensors like accelerometer and gyroscopes. Providing users with real-time feedback and insights into their daily physical activities, this app offers valuable applications in health monitoring, fitness tracking, and personal productivity, with added advantage of cross-platform functionality of both Android and iOS devices. For future work, expanding the range of recognized activities for more complex activities like stretching, dancing, or sports-specific movement. That's all. These are the reference for this project. So thank you.
Thank you, Shivani. That was an amazing presentation. Thank you so much. Any questions, attendees?
I have a question. Can you hear me?
Yes, sir.
So your project was quite amazing. So where do you implement this in real world?
In medical activities, sir, future work, we have to analyze the danger zone activities like submarines. We have to monitor the insecurities, sir.
Okay, you did unusual activities. You're saying what, right?
Yes, sir. Yes, sir.
Any other questions, people? Okay, fine. Thank you. Thank you, Shivani. Thank you so much for your presentation. So we'll move on to the next participant. Oh, it's Mr. Rajaram.
Yes, sir. May I audible, sir?
Can you hear me?
Yes, sir. Can you hear me, sir?
Yes, I can hear you, Rajaram. Yes, go ahead with your presentation.
Okay. So good evening, all. Today I'm going to talk about powerful combination that transforming how business interact with their customer in AI CRM. So next, my title is Artificial Intelligence Driven in CRM Business Strategies. Next, content of this presentation: what is CRM? why we use the CRM, key applications in AI and CRM, AI-powered AI-powered features in CRM, benefits for businesses and real-time tools, and features of AI in CRM. So what is CRM? CRM means customer relationship management. Stands for it's a system that helps business manage their interactions with customers, and CRM software can help business improve customer relationship, streamline processes, and increase profitability. So next, why use of AI in CRM? CRM handles huge customer data. AI helps to analyze and predict and automate, improves customer experience and sales and supports. So this is key applications of AI in CRM. Let me highlight 3 key ways to AI improve CRM. First is personalization. AI understands customer preference, recommends the right product and content, better targeting, and more conversation. Then predictive insights. Forecast customer behavior and identifies leads likely to convert or churn. Data-driven decision making that helps team make proactive action. Then automation, routine tasks like sending mails, updating records, or scheduling calls can be fully automated using AI, giving team more time to focus on customer. Then AI-powered feature in CRM. Some cool AI-powered features in CRM system includes, that's all, chatbots that offer instant support 24/7, and sentiment analysis that detects customer mood from messages, and smart lead scoring that helps to prioritize the most promising leads. All of those features work together to enhance customer satisfaction and increase sales. Then business fields. Benefit for business: faster response time, increased customer satisfaction, higher sales and retention, improved team productivity. Real world example for AI in CRM, Salesforce Einstein. This is an American company. It predicts customer needs, what customer will need. Then Zoho CRM with Zia, it's an Indian company. Smart suggestion for sales team. Then HubSpot AI tools, it's one of the US based company. It automates the email and lead management to the customers. So next, features of AI in CRM. Hyper personalization at scale. That means dynamically personalize email contents and offer for each individual customer in real time. Emotionally intelligent CRM. It emotional detection via voice, text, face to understand and customer sentiment. Predictive and prescriptive intelligence. Today, AI predicts what might happen in the future. It will also suggest exact actions to take for a best thinking. Voice enable CRM assistants like Alexa, Google Assistants to enable in CRM. It will make better decisions to the customers. Then AI plus IoT plus CRM integration, it's a combination integration. Imagine a CRM that tracks how often a customer uses a product and recommended a service checkup automatically. So these are all my reference: Salesforce, HubSpot, and Zoho CRM, Gartner Search, Forbes, Harvard Business Review, McKinsey, and companies. So thank you.
Thank you, Rajaram. Your presentation was so good.
Thank you, sir.
Any questions, people? Okay, fine, great. So let's move on to Vairamani. Are you ready?
Yes, sir.
Okay, Vairamani, you can go ahead. Yes.
So good evening, sir. Myself, Vairamani from Banyan Yadav Engineering College. My topic is on AI in healthcare, enhancing to accessibility and efficiency with AI. AI is a transforming our world to offering to immense potential. The AI streamline process across to the sector. AI can lead to more productive futures. Sir. So next, AI for the increased efficiency, automating tasks and the streamline process. Sir. The streamline process to the machine learning automated tasks. It predictive analysis to optimizations of resource allocation. Natural language processing improves the communication. AI's impact and efficiency of significance. There are 3 things: automated report generation, intelligent inventory management, streamlined customer service. The efficient customer service. AI chatbot provides to the instant support to the AI automated problem to resolution and reduce the wait times to the customer satisfaction. Benefits of AI chatbot: 24/7 availability, instant response, they supports help. Addressing potential challenges and ethical considerations. AI has limitation of bias in algorithm and job displacements or concurrence. Ethical AI development ensure to the fairness. Product user privacy promote to the transparency and the community to the maximum benefit.
Thank you, Manikandan. Thank you so much. Okay, let's move on to the next participant, Ms. Priyanka.
Good evening, and group present here. I am Priyanka, Computer Science Department from PSY. I here to share about topic called AI in finance. AI include machine learning and deep learning. AI adapts benefits or efficiency, accuracy, speed, and cost reduction. The futures of AI in finance. Emerging trends include enforcement and predictive learning. AI will shape the future of financial service. AI ethics and governance are increasingly important. The futures of AI is intelligent. Predicting market trends with AI. AI algorithm analyze historical price, news, and social media. AI models like RNNS and ARIMA are used for prediction. AI algorithm can accurately predict market trend. AI for algorithm trading. Algorithm trading uses AI for automated trade execution. AI offers speed, precision, and 24/7 operations. AI is used to manage risk in algorithmic trading. Speed and efficiency risk management 24/7 operation. AI in credit risk assessment. AI improves credit scoring and loan approval processes. It analyzes alternative data sources. AI predicts bias and improves accuracy in credit risk assessment. Challenges and limitations of AI in finance. Data quality and availability can be limited. There are challenges in model interpretability. We need to address ethical and regulated compliance. Tools and technologies. Fraud detection platform, anomaly detection model, transaction monitoring, biometric authentication. Thank you.
Thank you, Priyanka. Thank you so much for your presentation. Any questions, people? We'll move on to the next participant, Mr. Gokul.
First of all, good evening, everyone. I'm Gokul, representing PSY Engineering College from EC department. Today, I'm excited to present on the topic AI integrator holography revolutionizing 3D imaging. This is a cutting-edge intersections of artificial intelligence and holography with a tremendous potential across various industries. Let's go to the introductions. Let's begin with the basics. Holography is a technique that captures and reconstructs three-dimensional images. Unlike conventional photography, it allows viewers to perceive depth and spatial details. However, traditional holography requires complicated optical setups, intensive data processing, and often lacks efficiencies, making it less practical for widespread use. The role of artificial intelligence. This is where artificial intelligence, especially deep learning, comes into play. AI transforms holography by improving depth estimations, reducing noise, and speeding up constructions. With these enhancements, holography becomes more accurate, accessible, and scalable for real-time use. AI techniques in holography. Let's look at some AI techniques used in this field. Convolutional neural networks, CNNs, helps extract and understand depth and spatial features from 2D data. Also, generative adversarial networks, GANs, are used to create high-quality, lifelike holograms from minimal input data. Together, they reduce the need for complex hardware and enable faster and smarter 3D reconstructions. Applications in medical diagnostics. One of the most promising applications is in medical diagnostics. AI-integrated holography can generate detailed 3D models from ordinary 2D scans, assist surgeons with better surgical planning, enable remote consultations with immersive visualization. This improves precision, reduces risk, and broadens access to healthcare expertise. Let's see examples of this image. Holographic telepresence. Another exciting frontier is holographic telepresence. Imagine participating in a meeting where your team members appear as 3D holograms live in real time. AI makes this possible by managing real-time rendering and facial depth estimations, creating immersive virtual collaborations for education, business, and entertainment. Challenges in AI-driven holography. Of course, we face some challenges: high computational power requirements, real-time performance bottlenecks, and growing ethical concerns, like especially around deep fakes and privacies. These are the crucials to address as the technology matures and becomes more mainstreams. Emerging trends. The future is incredibly promising with trends like quantum enhanced holography for ultra high precision, neural radiance fields, NERFS for realistic interactive rendering, and AI optimized light field display that could bring holography to our everyday devices. These innovations will significantly boost both realisms and accessibilities. Future prospects. Looking ahead, AI integrated holography is poised to transform industries including healthcare, engineering, and human-computer interactions. By blending physical and virtual worlds, it offers smarter, more intuitive ways to visualize, communicate, and collaborate. Conclusion. In conclusion, the fusion of AI and holography is unlocking a new era of intelligent 3D imaging in faster, more efficient, and more meaningful than ever before, pushing the boundaries of how we see, interact with the world around us. Let's go to the keywords. Key terms that defines these evolutions are AI, holography, deep learning, 3D imaging, telepresence, and medical diagnostics. Thank you so much for your attention. I look forward to your questions and insights.
Google, that was an amazing presentation. Thank you so much.
Thank you,
Any
sir.
questions? You're welcome. Any questions?
I have a question. Okay, Mr. Gokul.
Yes, sir.
You talked about negative, I mean disadvantages like deep fake risks and privacy concerns.
Yes,
right?
sir.
Yeah, how to overcome that? What is the perspective on yourself?
Sir, to reduce this risk, faking and privacy matters, we can secure our system by debugging. Like now, ethical hacking is one of the most techniques to evolving technology, I think. Well, I cannot provide the real solutions, but we can, once any incidents happens, we can debug and fix the way, because it is a new technology, so I cannot give you a rightful answers for this.
Okay. We need proper authentication and authorization for the AI technology you presented.
Like the algorithms used in blockchain technology, it is very more secured one, sir.
Yeah, if everyone can afford this technology means it's nothing. Okay. So everyone can do any holographic image of anyone, right? Am I right?
Yes, sir.
Yeah.
Sir, actually, this holography technology is mainly impact in education systems, because the students can easily understand, because the atom molecules are already nowadays in India, the atom molecules, everything is drawn on board and explained. They cannot understand. But in holography, we can touch and feel the 360 degrees of in-depth potential, so we can understand easily. It will give our future generation won't change.
Okay. Good job.
Thank you, sir. Thank you, sir.
Okay, thank you, Gogul. Thank you so much for your time.
Thank you, sir.
Sivaranjani from Sedu Institute of Technology. Sivaranjani, you can share your screen.
Yes, sir. Hi. Good evening, sir.
Good evening, Sivaranjani. Good evening.
Good evening, sir. It's Sivaranjani from Sedu Institute of Technology. So, abstract of the project. Medical image segmentation and fusion are crucial techniques for extracting meaningful information from medical scans, enabling accurate diagnosis and treatment planning. This paper presents a novel approach to medical image segmentation and fusion using an optimized unit architecture. So, the unit model originally designed for biomedical image segmentation is optimized using advanced techniques such as attention mechanisms. So, additionally, an innovative fusion strategy is proposed to combine information from multiple imaging modalities. For that, we are taking MRI and SPECT images. The proposed model is trained to diverse dataset from to demonstrate its ability to handle variations in image quality, noise, and resolution. So our experimental results shows that the optimized unit outperforms traditional segmentation methods. So go to the next slide. Objective of the project is to develop a unit-based deep learning model for effective fusion of MRI and SPECT brain images to preserve anatomical structures from MRI and functional details from SPECT in the fused output, to automate the fusion process for consistent and reproducible clinical results. So, existing system of our project is traditional fusion methods like PCA, wavelet transform, and Laplacian pyramid have been widely used. Some model-based approaches use sparse representation or multi-scale decomposition but lack adaptability. So recent deep learning models like CNNs have shown promise but may not preserve spatial details effectively. Proposed system. So this work proposes a unit-based deep learning model for fusing multimodal MRI SPECT brain images. So the MRI and SPECT images are pre-processed and aligned before being fed into the network. So for that, MRI images are converted into grayscale images. So this is our architecture diagram. So the literature surveys I referred is the author Kaigou. Title name is Multimodal Brain Medical Image Fusion based on the improvement of generative adversarial network. The paper is published on 2021. Technical used is generative adversarial network. So the next one is PET and MRI brain image fusion using wavelet transforming form with structural information adjustment and spectral information patching. The paper is presented recently in 2025. The papers I referred, most of the papers I referred has in challenges like accuracy and quality, lacking accuracy and quality of the images. So our project is mainly focused on the quality and accuracy of the output image. So the conclusion and future advancement of the project is unit-based deep learning approach was proposed for the fusion of MRI and SPECT brain images. The model successfully preserved the anatomical feature of MRI and the functional information of SPECT in a single fused image. So compared to traditional fusion methods, the unit architecture demonstrated improved visual quality and performance. Matrices such as SSIM, PSNR. Sorry, future research can explore the integration of attention mechanisms. Also, we are planned to take in the modality combinations like MRI, PET, CT, SPECT, like that. So, thank you for.
Thank you, Sivaranjani. That was a great and fantastic job you have done. So, guys, I would like to thank each and everyone who has participated in this conference. So tomorrow we have a great session. Like we have a top experts from international speakers who is going to present you guys, who's going to give a demonstration speech about their experience and how AI works in different fields and industries. Especially they're going to talk about AI ethics and automation part. So I request each and everyone to come and join the session without fail tomorrow, which means April 6th, and the session starts at 6:30 p.m. Okay? Thank you. Thank you so much. We'll meet you tomorrow. Bye-bye.